All right, now we're going to move on to section 1-5 or 1.5, which is called Representing Linear Patterns. Now in this section, we need to know a few terms. The first is linear. Linear is defined as straight line, and you can write that in your notes. Linear is a straight line. Independent variables. Those are variables that you can change. Independent means variables that you can change. And then dependent variables, I apologize. So dependent variables are variables that are unknown. And so, for example, suppose we have an equation y equals x minus 2. We can decide which variable between x and y we want to be the independent and which one we want to be the dependent. And this is how we choose. If we want x to be independent, that means we can change x. So that means we can plug in whatever number we want for x. And if you make a table out of it, you would say, let's choose a number for x. Let's say x is 4. And so then y depends on what x is. Y is an unknown variable that depends on what x is. So x minus 2, or 4 minus 2, is going to be 2. This is an example of a linear equation, and here's why. You're going from equation to table here. And so if x is 3, then y is 1. If x is 2, y is 0. Now, if you go from table to graph, like you did in the last chapter, then what would happen is if you graph these, it would look like this. It would look something like that. I might be a little bit off. But you would end up having a straight line if you connected the dots that you drew in there. Which means this, which creates this graph in the end, is a linear equation. All right, now we have something here. Y equals mx plus b is the general form for all linear equations. And you already know that y and x are variables, and x is going to be the variable that we change. So that is the independent variable. Y is going to be the variable that we don't know. Now, what are m and b? M is going to be, how do I describe this? M is going to be the rate of change for y. And so whenever you plug in something for x, how does it affect y, or how does it change y? And a lot of people consider m to be the slope. So you'll learn about that later on. For now, I want you to write slope in there. And then for b, I want you to write the y-intercept. Okay, so if you were to graph, or if you were to make a table out of this equation, here's what would happen. Suppose that you want to start at x equals 0. So you have your x column and your y column here. You want to start at x equals 0. And then you want to plug in x, and you know that anything times 0 is going to be 0. So when x is 0, this entire part is gone. Mx is gone. So all you have left is y equals b. So therefore, where x equals 0, y equals b. And if I were to write an example for this, suppose that my example is y equals 2x plus 1. That would mean where x equals 0, y equals 1. Now, what the m does is it tells you for every 1 that you go up in the x. So when you go from 0 to 1 in the x, the y value goes from here, and then it goes upwards m steps. And so if you remember from the very first chapter, we did the constant difference. The m is the constant difference. So you're going to have m. And in our example, we said that m is 2. So if it's going 2 steps up from 1, then the next term is going to be 3. So in the red we have our example, and what the example is saying, where x equals 0, y equals 1, because there's a 1 right there. And then where x equals 1, y equals 3, and the reason why is because our starting point of 1, we add 2 to that, and that's what m is, the adding, and then we get 3. Now suppose we want to go a step further, and we want to see what 2 equals, and we need to make another step. So you add 2 more, and you get 5. So there's one more thing I want you to know. Going from the equation to the graph. Now, in an equation, you have y equals mx plus b, and earlier I said this is the slope, and this is the y-intercept. And going from an equation to a graph, you may start to understand these terms. The y-intercept is where your straight line, according to this equation, hits the y-axis. So, if the y-axis, or if the y-intercept is b, and b is 1 in this example, then you would put a point on the y-axis at 1. There is your y-intercept, and there is the way to find one point on the graph by using your equation. M, though, you use it differently. With m, what you do is m is the slope, and m describes how far over and up you go. And I want you to think of slope as this: rise over run. What rise over run means is if m is 2, that means 2, you go up 2, and you go over 1. So to find the next point using your slope, you'd go up 2 spots and over 1, and you'd have a new point. Now, suppose that your m is different. Usually you'll be able to tell, or you'll be able to see that that m is rise over run, because you can put any number into a fraction, and 2 is 2 over 1, and that way you can say rise is on top, run is on bottom, and since rise is 2 and the run is 1, you'd go up 2 and over 1. All right, so with all that said, your notes are difficult to fill out for this chapter, and I want you to ask me to help you. What I would also like you to do is I would like you to, on your notes, go to the back, and you'll have 3 sections. You'll have standard form, table, and graph, and then there's 3 sections going down. The first one has an equation, and I want you to try to use the equation to figure out what the table is, and then to figure out what the graph is. And then I want you to use the next one, the next table, to figure out what the equation is and what the graph is. And so your table, you're going to find out what m and b are. You're going to put them into the equation.